Welcome back to SKAM's assembly explanation video. I decided I would split up the video into two parts since I thought it was getting a little long. This will be the final part. This won't be as long. I just finished talking about the gear mates. Now I'll move on to a couple of these mates that are left. Here's this concentric mate. It's the same idea that I've been talking about for this entire subassembly. So if I were to suppress it, then basically this is able to move freely, and if I unsuppress, then now it gets locked in place. So this mate was needed so that this would move with and be able to push the sprockets forward and back and be able to rotate them. Then we have coincident mate. It's the same idea as before. If I suppress this mate, then these two prongs will be able to move through each other, and that is not what we wanted. We needed this top prong to be on top of this other gear insert so that it would be able to have a screw go through it, so that it would be, or not a screw, a shaft with a shaft collar, so that it would be able to be pushed forward and backward like you can see right here. Okay. This is a concentric mate right here of the hole inside this plate and the pole itself. So if I quickly suppress this mate, take it out, everything just gets broken. So we really need that concentric mate to put the pole in line with the plate right here. Now I need to fix this. There we go. This is a coincident mate in between the plate and the pin plate. Oh, let me highlight it again. So if I suppress this, move, it won't move because it's fully defined, but if I were to move it, it would basically move inward and outward of the pole, which is not what we wanted. We wanted this back edge of the plate to be coincident with the outside part of the pole, and they would basically be glued together. Okay, let me zoom out again. Almost there. Right here we have a coincident mate between this face and the bottom face of this custom rod. So we have that so that the custom rod does not move in through the end of the pole and that it stays on top. I'll quickly suppress this. The rest of these mates are basically redundant, so it'll be fast now. So see, as you see, it can move through, and that's not what we want. We want it to be on top so that I can push these rods so that they can rotate the gears or the sprockets. Let me unsuppress, and now it's back in place. The rest of these mates right here are what I've already talked about. It's just the redundant mates. It's concentric and coincident mates that basically prevent the pieces from being out of line, and it's just the other side of what I've already talked about. So I'd already talked about one side, now it's just the other side. As you can see, if I highlight it, that's a concentric, that's a coincident, it's another concentric mate, that's another coincident mate, just to keep everything in line. Now here I have a parallel mate with the top faces of the end of the pole and the base. This was very important because if I suppress this, and these components are fully defined right now because they're fixed and fully defined. But basically what was happening before they were fully defined was, because this was not parallel, this face was able to rotate into the top face, and that was messing up the alignment with this custom rod, and that is not what we needed. We needed this top face to be parallel with this top face of the base so that there would be no rotation. So I unsuppress it, and now it's not showing, but basically the idea was that this basically is parallel to this so that this does not move around. Here I have a distance mate, and this distance mate is very important because it keeps, it's between this point right here. You can't see it because this handle is covering it, but it's between this point and this edge of this rod here, and it's a set distance so that when we push the sprockets, they don't get completely out of, you see this? It's moving along this custom rod, and that's not what we want, because then we won't get that full translational movement and we won't get the maximum rotation out of the sprockets. So that's why we needed this mate, and we set that distance mate to basically secure it in position so that there would be much less rotation lost, because there's not the same amount of movement along this custom rod of this prong. The same thing is shown here. This is a parallel mate so that this edge and this edge are always parallel so that they move together. So if I take this out and suppress it, then you see that it falls out, and that's not what we want, because again, it needs to move in line so that the handle can right here push, and everything can work accordingly to that. Let me unsuppress that. Okay, so now you see it's much better. Finally, we added in the handle right here. We added 2 concentric mates through both ends right here of, oh god, there it is. Okay, so we added concentric mates through both sides of this custom rod, so right here and right here with the handle, so that it would always be concentric when it was being pushed or pulled with the custom rod. Because if I were to suppress one of these, then if I push, you can see that it's just falling out, and we can't have that. So that's why if I unsuppress, it comes right back in like that. And now if I were to push, it works accordingly and is able to completely push forward and backward. And then this parallel mate is the last mate I'll talk about for the subassembly. This mate basically ensures that these 2 back faces of the custom rod, which is this, and the handle, are moving together the entire time, and they're always parallel. Because if I suppress and I push, this pushes outward, this turns this way, this turns that way. That's not correct. That's not what we need. So I unsuppress and it comes back to where I need it to be. Let me just Control Z because everything got a little messed up. Okay, there we go. So I'm just going to save this real quick. Now I'll move to the main assembly, which is much shorter than this. This is the final assembly. So that was the claw subassembly. So the claw subassembly was inserted into this forearm part of our assembly. So I'll talk about that at the very end because that's at the very last of the mates. Let me just quickly talk about these coincident mates. So if let me just pull this out for now because we don't need that there for now. We have these coincident mates right here, and they basically join this top half of the cylinder to the top face of the upper arm. It's very important that we have this. If I suppress it quickly, now this can move anywhere, which is not what we need. We need it to be coincident with the top face so that it can slide in and out. So unsuppress, and now it's back in line. The same idea is present with this coincident mate. It's just with the side. This is the mate that really locks it in place, because if I suppress this, now this can move anywhere. But if I unsuppress, now it becomes in line with that sliding part that we have right here. As you can see right here, or let me zoom in a little. The sliding part becomes in line with that so that I can slide inward and outward. Okay. A couple more coincident mates. This coincident mate was added to basically join the top and bottom halves of the arm. So if I just took this mate out, I think I'm clicking on the wrong part. Oh, it's because it's become fully defined. But basically what would happen is if I take this out, this top half can basically rotate around like this, and we want it to be joined to the bottom half. So that's why we added this coincident mate. And we also had to add a couple other mates, but I'll talk about that after, to join the top and bottom half. This is a very simple coincident mate right here of the track and the cylinder portion. If I suppress this, this can move up and down through it, which is not what we need. We need it to be in line. It's unsuppressed, and now it's in line. So this is that coincident mate I was talking about earlier. We also had to add let's see here. I think there's a small coincident mate right here. So that coincident mate basically keeps these two portions together. You zoom out, come back here. This is one of the more important mates that we had. This is our crank. We added a concentric mate with this hole that we have right here so that it would slide in and be able to go into that hole. If I suppress this mate, you can see that it's able to move every which direction, which is not what we need. If I unsuppress, it goes back into place, and now it's in the place that we need it to be in. This coincident mate, it's a very simple one. It's just to secure the top and bottom arms together. Because if I just added that earlier coincident mate I showed you, then the top and bottom halves could still rotate around about each other. But this is what really secures it in place. So I think if I suppress this, let me see if it's gonna work or if I need to unsuppress other ones. Yeah, if you see this, it's rotating. The top half is rotating on the bottom half, but we need it to be basically locked in place, right? So that's why we had that made, so that it locks those parts together. We also added this concentric mate. That's the skinnier portion of the crank, and it goes through the gear. And this mate is really important. If I suppress it, now this entire part can go through, which is not what we want. We just want this part to be able to go through the skinnier portion, because that's what's going to go through the gear. So that's why we added this mate. Unsuppress it, now it's fine. Now it works. Almost there, a couple more mates to go. This is a coincident mate between the left face of this gear and the right face of this upright to keep that in position. That's basically to secure the gear. In the real assembly, like when we printed, we had this evenly spaced in between, but for the sake of the assembly, we had this mate so that the gear wouldn't just be, moving wherever it wanted to move, so that it would be locked in place right there. Just two more mates to go, and we're finally going to be done. Let's see here. So this is a concentric mate between the inside of the cylinder and the pole that is inside of the cylinder. If I were to suppress this, let me see here. If you see now, this is basically sliding through, which is not what we want. We want the pole to be inside of the cylinder. So that's why we added that mate, so that those stay aligned with each other. Unsuppress, now it's back inside. And then that coincident mate is what I've already talked about earlier in the subassembly. Let me just double check that I've gone through everything. Talked about that, talked about that. So that's it. And we finally have, I think it's gotten hidden. I think we accidentally hid it in the mates. This is the final mate, probably the most important mate. There's a concentric mate right here with the cylinder and this opening right here, so that this cylinder basically slides in and out and does not get rotated, or does not fall out of the arm itself. But there you have it. That's the entire assembly. That's the rundown of why and how we chose our mates. I hope you liked this video. Sorry that it was so long. I tried to be as non-redundant as I could be. Thank you so much for watching.